Lookahead is another kind of an optimizer. Let's call it sort of a meta optimizer. So here's the idea with Lookahead. Lookahead, the idea is, let's say we're here, okay? We have got our current parameters, and we are going to go ahead and take some steps in whatever optimizer, based on whatever optimizer we want. So we could be using NATM, we could be using RMS prop, whatever, it doesn't matter, AtomW. And so we take, let's say, some steps. Something like that. Okay, so we take a few steps. We take k steps of what's called the fast optimizer. And then we mark, so this is where we started, and this is where we ended. And now we take some linear interpolation between these two. So if we look at this as, so let's say this is time t. So this is theta t plus 1, theta t plus 2, theta t plus 3, theta t plus 4, theta t plus 5. Plus 1, plus 2, plus 3, plus 4, plus 5. And this is what we would get for, this is our calculated theta t plus 6. And what we're going to call this one is, let's say, phi sub I. And so what we do is, so this is basically the start of the beginning of the k-steps of the fast optimizer. All right. And what we do then is we do a linear interpolation between here based on a parameter alpha. So what we say is phi of I plus 1 equals, well, what would it be? We want to be k steps between here and here. So we're going to be phi of I plus some k times theta. So all this is really saying is we're going to go a proportion of the way between here and here. And I'm sorry, this isn't k. So this is, right, this is our alpha. So basically, it's the percentage of how much we're going between here and here. So if alpha is, let's say, 1, then we're going all the way to here, and it's as if we're not doing anything. We have just our fast optimizer working. If alpha were 0, we would just be stuck here. We're never making any progress. If alpha is a half, which is a normal default, then this is our phi of I plus 1, and it's also equal to our theta t plus 6. So here's the initialization we're going to do for our Lookahead optimizer. And this Lookahead optimizer, again, is what we're going to call a slow optimizer, and inside we have some other optimizer. So this might be Lookahead plus we might have, let's say, Atom as our fast optimizer. Okay, so we've initialized it in that way. We have phi, which is empty. We have I, which is 0. That's part of our initialization. And then our optimizer step, so our Lookahead step, this is one step of the optimizer, is going to do what? So our normal SGD step is, right, theta equals theta minus lambda times the gradient. Here our Lookahead step looks like this. Well, first, if phi is empty, phi equals theta. All right, so that gives us just a base case. So when we're very first starting, we're going to say whatever theta was initialized to, phi is going to be a copy of theta. And then we go ahead and run the fast optimizer step. We increment I. And then what we want to know is when we get to here. So this basically, we want to say, okay, if I mod k equals 0. So we've gotten to here. Now what we need to do is both update phi and update theta. So what are we going to do? We're going to say that phi equals phi plus some constant k. Sorry, let's back up a second. K, where did this come from? So k is a hyperparameter. We have another hyperparameter as well. So our other hyperparameter is alpha. So we are going to go basically some amount of the distance from here to here. If alpha is 1, that means we're going to go all the way to theta. If alpha is 0, that would mean we would staying at phi. And if it was half, which is a common value of alpha, then we go halfway between. So this is another hyperparameter. And then theta equals phi. Let's go through again what we're doing here. So we've got our look-ahead step, right? Our look-ahead step says we've initialized phi to empty and we've set I to 0. This is some initialization we do. We have two hyperparameters, k and alpha. And our look-ahead step says this. Well, if phi is empty, let's go ahead and initialize it to theta. So this is at the very beginning of our gradient descent. And so we are starting wherever we are with our random theta. And what we want to do is initialize phi to that. Then we run our fast optimizer step. Whatever fast optimizer that is, it could be regular SGD, it could be SGD with momentum, it could be atom, it could be whatever. We are adding in look-ahead on top of any other standard optimizer. And then what we do is we go ahead and run that step in increment I. If I mod k is not equal 0, that means we're at one of these. Okay? We're at one of the intermediate steps where we're just letting the fast optimizer go. And then if we get to the end, then what we do is we say, okay, we're going to update phi to be whatever phi is now plus alpha of the way from theta to phi. So if alpha is 1, that says we go all the way to theta. If alpha is 0, we stay at phi. And if alpha is, for instance, 0.5, which is a good value of alpha, a good default value of alpha, then we go halfway in between. So this is going to say phi equals, so this updates phi, so now phi is, let's say, halfway between, if alpha is 1/2. And then we update theta to be equal to phi. So that causes that. So one way to think of this is, what we're doing is we're letting the fast optimizer be a little more adventurous than we might otherwise. So for instance, we might use a larger learning rate than we normally would do. So think of it as we're on a mountain and we're descending the mountain using gradient descent. Okay? However, what we do is every k steps, we're going to go ahead and plant ourselves in. Let's say there are two of us. So one of us is going to stop and let the other one go forward k steps, holding a rope, let's say. So if they get in trouble, then if they get at the bottom of a ravine, for instance, we're going to now update where we're going to go halfway between where we are and where they are. So we're going to get them out of sort of what trouble they are because we're not going to go all the way in that direction. So we will stop. We will let them go k steps to wherever they end up. We've got our rope now, and then we both start going back on the rope and meet in the middle, or alpha of the way of the rope. So it acts as this moderating influence on the fast optimizer. It's funny that there are all these namings, right? So the combination of this with that gets its own special name. There is a version of Atom called RADAM for rectified atom. So RADAM plus Lookahead equals Ranger, right? These fancy sounding names. So Ranger is this combination, but really you can use Lookahead with any optimizer that you would like. And so the goal again is you can run your fast optimizer slightly with hyperparameters that make it slightly more aggressive. And then the Lookahead will act as a moderating influence.